In this video, we are going to cover the material presented in 1.1 to 1.3. These are the section numbers of your textbook, Building Java Programs, BJP for short. The topics that we will review are how to write a simple Java program. The IDE that we will use is the JGrasp IDE. We will compile and run the program and talk about documentation, some of the syntax and logical errors that we need to watch out for, what is naming convention, and then move on to methods, the importance of methods, how we can bunch up a set of statements and give them a name and call the name so that you can execute a certain task. So that's what in general methods are meant for. And they are core of Java programming language. Java is an object-oriented programming language, and but in this course we will stay mostly with structured programming, which means we will talk about the features of input-output, of decision-making, of repetition, and so on. And towards the very end, we will move into compound data types and a little bit about core object-oriented programming, which is classes. The reason why this has to come up now, because when you look at a Java program, you will see the word class. And everything in Java needs to be wrapped up inside a class because it's an object-oriented programming language. Now, we will also talk a little bit about procedural decomposition, high charts, execution charts, and then we will stop there for this week and take it up with more of procedural decomposition for next week. To our JGrasp. And as you can see, this is a taskbar that you will see when you download the JGrasp IDE. You will get help in the lab for downloading the IDE, and you will get an overview and some documentation. But just briefly, if you go into File and you do New, you can select Java, which is what I did. And you can also save the file as, and if you save it, you can save it onto your device, onto any folder that you want. Now, if you look here, as you can see, my path is on my desktop. It's on my desktop, and I've got a folder called CSC15 JGrasp, and that's where all my programs are going to get stored. So I need to have a class here, and when you save this program, the name of the file is going to be the same as the name of the class, and we'll see that in a minute. So the outer envelope consists of the class. The inner envelope, if you will, consists of a method. So what do we mean by that? Here, this is not going to make a whole bunch of sense to you just now, but just stay with this. Public static void main string args. This is something you can just take for granted, and that there is going to be a main engine or a main method that's going to run the program. Here is where the program starts to run. Now know that there are curly brackets here, matching curly brackets that envelop the class, and then matching curly brackets that envelop the method. So this is, again, a syntax issue that we have to watch out for. Now, what does this mean? We don't need to worry about it. It just means that there is only one method, which is the main method, which starts your program just like the engine of the car. Now let's just do system.out.println. This is a simple command which tells the system to print whatever is in the quotation marks onto your screen. So if I say hello world, then this is what literally everything that's between these two quotation marks is going to get printed as it is. If you do not print them, then that's going to be an issue, and everything ends with a semicolon. It's just like this is the end of my sentence. Now I'm going to look up and see this icon here which says compile the program. What is the meaning of compile? Compile means that, well, this program is written in English, but the machine cannot understand it. So we are going to translate it into bits and bytes so it can be fed into the machine. So let's do that. And yes, I would like to save the file and give it a name, calling it first.java. So this .java is called the extension, and all your Java files are going to have that extension. So let's save that. And now, if you look on the left side, you will see my first.java, and the compilation process has created a class file. This is a binary file and you won't be able to read anything inside it, but that's a kind of thing that the machine likes. Now I'm going to look at this running man icon and run it, and I actually see the output here, which is hello world. So we have written our first Java program. Now, let me make a change here and talk about what are the possible errors that we can have. And let's not put those quotation marks, and let's try to compile our program. You see, now this says here that you had an error. The error message is popping up here, and it also gives me the line number. So at line number 5, it says, I'm having a difficulty processing this, and it tells you where the error is. So I'm just going to go back and fix it. So this kind of error is called a syntax error. And what I did by fixing and going back and putting those quotation marks is called debugging. Now with that being done, I'm going to say, well, all right, how about I try to draw a picture, system.out.println. I can make pictures, and I'm going to have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. All of this is 5 spaces here. And I would like to create a picture. Actually, let me do this. System.out.println, and here I'm going to do 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, stop, and this is my picture. And I'm going to compile my program one more time, and then I run my program, and as you can see, I get the output that I was looking for. This is my picture. Now I would like to, I have now 2 commands. One is print the top part of the picture and print the second part of the picture. I would like to give this task a name. So when you would like to take a bunch of statements, in fact, you know, what if you wanted to do something more? System.out.println, and then I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then stop here. So this is going to be I've got 3 on this side and I've got 3 on the other side. That looks good. So I would like to say this is my picture, and I would like to say something like draw picture, and not say, you know, print this line and then print the next line. So I'd like to give a task name to this. When you do this kind of thing, this is called creating a method. So let's create a method called public static void draw picture. I'm going to call this draw top picture, and you'll see in a minute why. And now you might be thinking, what am I doing and what am I inserting? You see, this is the beginning of my main program, from this curly bracket to the other. Under that, I've created a place where I can move these statements and bring them right here. So now what I'm going to say is, I've got a task called draw top picture, and this task is called a method. Note that everything is going to be public static void for now. This one has some gobbledygook here. This one has nothing. This is called parameter list. It's going to be empty. You don't need to worry about it just now. And then finally, we do need to have something that finishes. So when you click on this, you will know. So this one, everything needs to be enclosed in the class. So we've got this curly bracket matching this curly bracket. and everything is between this curly bracket and the last curly bracket. So we have main here, and under main, we've got a task or a method. And now this is called the method definition. And here I'm going to call method call. And what's going to happen here is I'm going to say draw top picture. This is called the method call. Know that the method definition has already been done here, and now I'm calling the method to do these tasks for me. So let's compile this, and then let's run this. And you will see that it has drawn the top picture for me. The advantage of doing a method definition and storing this somewhere is that we can, in fact, now do draw top picture one more time and compile and run, and we find now that we were able to draw two pictures. So instead of having 6 lines in your main program, because you gave a name to the task, you were able to call that method or accomplish that task by calling the name, and you can do this multiple times. So this is a big advantage, and this saves on code, and it's called code reuse. So that is what we're doing, writing the code in one place and using it as many times as we need. So that's one advantage, right? The second advantage of having methods is what if we wanted to make this picture a little more complicated, and so our task was not just to draw top picture, but we had a bottom picture as well, right? So what we want to do then is create a public static void draw bottom picture, and here what I would do is I'm going to do the reverse of the top picture. So I'm just going to save a little bit of typing here, and so here we go. It's actually gone in. Yeah, there we go. So now I have two method definitions to draw top, and here I have a definition to draw bottom. And if I do draw top picture and draw bottom picture, then what I get, it says I've got an error with 24. All right, somehow the other one, okay. So now you see I've created this beautiful picture. And so if I started to look back and say, if I wanted to create a picture that looked like this, I can split my task, my big task, into two tasks. I can say, well, I can draw the top part, and then I can draw the bottom part. This business of taking a problem and breaking it into smaller parts is called procedural decomposition or top-down design. It would have been absolutely fine for me to have a main program with 6 lines that look like that, but that's not procedural decomposition. That's writing a lot of hard code, which you will see in a minute is not such a smart idea, because what we want to do is just like if you wanted to assemble a bike, then we know that that if you go to a bike factory, they don't actually manufacture a bike as such, but a bike is divided into wheels, it's divided into the seat, the chain, the handlebars, and so on. And sometimes all of these pieces, they are manufactured by different factories or different companies, and sometimes they're imported from all over the place. And then there's one place that purchases all of these things and assembles it together. So software engineering is exactly like regular engineering in that we are going to make the different parts and we are going to combine it together to make the product that our customer is looking for. So in the end, what may happen is that someone may be a wheel expert and make wheels of different sizes. Someone may be a handlebar expert and make handlebars of different sizes, and so on and so forth, and then construct a bike, get all of these parts and construct a bike in whatever manner that is comfortable or needed by the customer. So look at the other advantage of this. So this procedural decomposition is huge. What if I wanted to change my picture tomorrow and have it look like this? Well, then without changing my program, I was just able to change the position of my method calls and create a completely new picture. If I did not do that, I may end up in my main program having 50 lines of code that I need to change. So having these parts designed and ready, and then you can assemble them in whichever order that you want, is procedural decomposition, and that's what we're going to be following, right? So now we have, and in addition, now I can do this. Write the code one time, use it multiple times, code reuse. There we go. Let's run this. And now we have an even bigger picture, which is, looks like this. Where did that go? Yeah. Right? So here's our picture. So this is a very, very important feature, and that's why we are starting to program in this way so that we stay with this. Now, with regard to naming convention, know that method names and later on variable names start with lowercase. They're descriptive. They describe what action is being done. It's camel casing. First word starts with lowercase and then uppercase and uppercase. So take a good look at this program when you're reading your textbook just to compare and see that all of the word and verbiage that you're reading actually makes sense when you're sitting and working on the computer and programming. So now what I'd like to do is I'd like to talk a little bit about structure charts and open up my PowerPoint so that I can, So if you remember, then we had a main program. The main program called, let's just keep it as draw top picture, and this was our main. And then we had a draw bottom picture. This is called the execution chart. This is level 0. And this is level 1.1. And this is 1.2 because the main program calls these methods. And this is the first method in level 1 that's called. And this is the second method that's called. This is called the execution chart. And the hierarchy chart, it gives the structure of the program in that what are the components of the program? The components of the program are draw top picture and So if you are asked to create a hierarchy chart, then know that this is what a hierarchy chart looks like. You start with the main program and you look at the components inside your program, and then you draw the chart indicating that the main program, it consists of two major blocks. That's draw picture and draw top picture and draw bottom picture. You could have done draw bottom picture here and draw. So now if you look at these lines, note that this line is repeated here and it's also repeated here. What I could do is I could take this one notch further and say, how about I create some more methods which are even more descriptive. Public static void draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Draw 15 lines is just this method. And then you've got another method here, public static void. This one is 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to nine lines is going to be this one, and then draw, I'm sorry, not lines, but stars. And here I will have public static void draw 5 stars right here, and this is going to be this one. Now what I could do is, instead of having these print statements, I can see that I need to draw 5 stars here. So I'm going to call this method draw 5 stars. And here, draw 9 stars. And draw 15 stars. And here I'm going to go the opposite way. Draw 15 stars. Draw 9 stars. And draw 5 stars. So now my program consists of draw, let's just keep it to draw top and bottom. Draw top picture, and when we go into draw top picture is a method which calls another method. So this is an important feature for you to remember, that methods can call other methods. And this method is defined at the bottom here, and it consists of just the single line, which is print 15 stars. And the same thing for all the other drawing stars business. Each one has got its own little method. Now let's try to run it to confirm to ourselves that for some reason the last one gets. Here we go. So our program works perfectly fine, even though we changed the internal part of it, did some software updates, but our program is working exactly as before. Now I'd like to remove this. Now what I'd like to do is for us to go into our PowerPoint and see that what we have now is the draw top picture. It calls draw 5 stars, draw 9 stars, right? And it calls draw 15 stars. I'm just going to say 5, 9, and 15 because I think you know what I mean. And draw the bottom picture calls draw 15 stars, call 9 stars, and draw 5 stars. It's our main program, which is at level 0. And then here we have draw top picture. And our draw top picture calls draw 5 stars, and then draw 9 stars, and draw 15 stars. So this is at level 0, this is 1.1, this is 2.1, 2.2, and 2.3. So execution chart is now getting deeper. This is the 0 level, this is the first level, and the indentation, they correspond to the method calls that are inside the previous level. And of course, then at our 1.2, we will have draw bottom picture, and that will have its 2.1 draw 15 stars, etc., etc. So, so when you're asked to create an execution chart, then this is what you are expected to. This is what you're expected to do. You're expected to write these numbers here, indicating the level and the procedures the methods that are being called. All right. So now I'd just like to end with one last thing. And what I'd like to end with is the advantage of this kind of what might look like hair splitting is that now I can say my top picture may end up looking like this. I can add more features into my draw top picture by just calling 5 stars multiple times, and I can change my bottom picture by doing something like this. So now that I have these smaller components ready, I can create fancier and fancier pictures. See that? Now my picture has become fancier because I'm using a combination of all the small components and fitting them together to form picture. And I'm not writing any new code. I'm just using existing methods that I have created, right? Okay, so I think we have covered the topics of procedural decomposition, taking a big idea and splitting it, looking for patterns, and splitting this big task into smaller tasks, and splitting those smaller tasks into still smaller tasks till we are not able to split that task anymore, or we have a reasonably manageable small task that we can save in one method, and then connecting all those methods together to solve the bigger problem. We have also gone over hierarchy charts and execution charts, and we've also done a little bit of naming conventions and syntax and syntax errors. Logical errors we will go into next time. Those are what if your program appears to be working, but it's not giving the result that you want, right? So we will go into that next time. But for now, I think this pretty much covers most of the features that are given in 1.1 to 1.3. But you should also, of course, read the textbook and do the lab and do the practice exercises from Practice It to understand more deeply and practice more deeply the concepts that are there in this first part.